Hello everyone. This YouTube video is the Machine Learning Using Python project assignment for Sci-Fi Labs online course. This video is made by Dr. Pichumani Angirkani of Lady Doak College as part of the assignment of Machine Learning Using Python course for Sci-Fi Labs. The problem statement which I have taken for my assignment is prediction of breast cancer using machine learning algorithm. Now I am going to explain you the code window of my project. First I have imported all the libraries. The first library is NumPy, which is a powerful n-dimensional library, and I have also imported Matplotlib, which is a library which is mainly used for creating static, animated and interactive visualization. And I have used the Pandas library, which is the library which is mainly used for data analysis and manipulation. And then I have used the sklearn from scikit. Datasets is mainly used to import our dataset. And the dataset that I am going to use here is the cancer dataset, which is a inbuilt dataset which is present in scikit. And I have used for quantifying the quality of prediction, I have imported sklearn.metrics, and I have used to split the training and the testing data set. I have imported the model selection from the sklearn. Now, the first step that we are supposed to do is we have to load the data set. So the default data set is load_breast_cancer, which is being loaded into the variable called cancer, and the second statement cancer.describe is used to describe the entire data set. As you can see here, this cancer data set is taken from the breast cancer Wisconsin diagnostic dataset. Total number of instances present in the dataset is 569, and totally there are 30 attributes which are numeric, and the final attribute is nothing but the class distribution, which is 212 malignant and 357 benign cases are there. The second step what I am going to do is I am going to put the data into the Pandas data frame by using the particular method called pd.dataframe. I am importing the cancer data and the feature names, all the columns except the class variable. So data 1, when I give, it will describe all the data that are present. So totally 569 rows are there, and you can see the 30 columns that are being present here. To this particular data frame, I am just adding another column that is called target. In order to add this column to the existing data frame, I am first assigning this particular column called target to the variable called target by using pd.dataframe. Now I have two variables. The first variable is data1, which consists of all the column names, the feature columns, and the target variable, which consists of the target, which is either 0 or 1 to define the benign or the malignant condition. Now I am going to concatenate this particular data with the target variable column wise. For that I have used pd.concatenate. Data1 contains the feature variables and target contains the binary classification as 0 and 1, and I display the data by using df.h, which displays the first 5 rows of the given data set, and you can see here the target is 0, and if I want, I can change it to df.head of 10. This will display me the first 10 rows, and if I want to change this one, I can display 100. If I run, this will show me the first 100 rows. So as I scroll this one, you will be able to see the classifications clearly. The target variable is either 0 or 1 in this particular case. Now to describe all the feature columns that are involved, And to compute the parameters by each column, I provide a statistical description of the dataset by using df.describe, and I am rounding it to 2 decimal places. So the total number of mean radius that is present is 569. The mean value is 14.13 and standard deviation with the minimum and the maximum value that is present with the percentile calculation is given here for each of the column that is being involved in this particular case. And then I am obtaining the correlation which describes the relationship between the variable. Here I have used the Pearson correlation. As you can see in this particular diagram, just double click so that it enlarges. It shows the relationship between the various columns with respect to the target variable. So it is the worst concave is highly correlated to the target variable. We can't use a linear regression here because the classification or the classifier or the data set that is used is a binary data type. Because it's a cancer data set, we have to classify it as either 0 or 1. So I'm going to use here the logistic regression, which is followed by other classification technique. So in this case, the first step what I'm going to do is I'm going to print the information of this particular data frame, which is my DF. You can see all the variables, everything is a float data type and the target variable is int32 data type. And since it does not involve any pre-processing because there is not a null column, there is no null column that is being involved in this particular case. No pre-processing is required and no categorical variable is involved, so that we need not use any one-hot encoder technique over here. So therefore what I have done in this particular case is, before performing the training and testing, I wanted to show you the visualization of each of these things with respect to the malignant and the benign condition over here. First thing is I have used Seaborn to create a heat map which shows the correlation between various features, as you can see in this particular case. And this is a box plot which clearly shows how many of this mean underscore texture correspond to the target value of 0 and how many belongs to the target value of 1. The same thing has been done for all the feature variables here. And as I told you earlier, it does not involve any null variable or not a number variable, which you can see it from here. I am moving to the machine learning algorithm where I need to split the given data set into a training and the testing data set. To perform this one, what I have done is I have taken the columns 1 to 29 as X and the target, which is taken as the Y variable. And now I am using the split case, that is train underscore test underscore split, where I am splitting the given data set into the training and testing data. And here I am going to use 25% as my testing data set, and the remaining 75% will be my training data set in this particular case. I'm going to apply the feature scaling technique here, which is followed by the various types of algorithm. The first algorithm I have used is the logistic regression, where I am using this classification technique to fit into the given training and testing data set. The second classification is k nearest neighbor, and the third classification method that I am using is SVC method of SVM class to use support vector machine algorithm. The next one is SVC method of SVM class to use kernel SVM algorithm. Then I have used Gaussian method of Navy Bayesian classification algorithm, followed by a decision tree algorithm. The last one is the random forest algorithm. So I have used here 7 classification technique, and we are going to see which one gives a very high performance in the case of the breast cancer data set. So I have trained this particular model. Now when I apply the test case to predict the classification accuracy by using classifier 1.predict on the given test data set, and I am storing it in the appropriate variable y underscore predict 1 for classifier 1 till predict 7 for the last classifier. Then what I am doing is I am printing the confusion matrix and I am storing it in the variable from CM1 to CM7, and here I am just showing the confusion matrix using the heat map between the predicted value and the true value in this particular case. The next one, I am printing the accuracy of each of these classifier. As you can see here, this is in the case of logistic regression. For 0, the precision is 92%, for 1 it is 96%, and the accuracy is 94% for logistic regression. For k nearest neighbor, it is 96%. SVC method of SVM class to use support vector machine algorithm, it is 97%. Again, using SVC method of SVM class to use kernel SVM algorithm, it is again 97%. In case of Navy Basin, it is 92%. And in case of decision tree classifier, it is 94. In case of random forest, is 95. So among all these classification techniques, SVM algorithm performs best. Thank you.